Chapter 9, Trigonometric Ratios. This is the sine rule now. This is part 2, so questions 9b. I'm going to prove the sine rule, and then I'm going to have a go at question 11 from exercise 9b. The sine rule deals with situations where we are concerned with two angles and two sides. The cosine rule, you may remember, deals with situations where we are only concerned with one angle, but concerned with all three sides. So if you have a question where two angles, two sides, it's probably sine rule. If it's a question which has three sides and one angle, it's probably cosine rule. So here's the proof for the sine rule. I'm going to drop a vertical down as I did with the cosine rule. I'm going to call it x. So that's the standard diagram. This is side A, this is side B, this entire length here is side C. Okay, first off I'm going to look at this little triangle here. Just using standard trigonometry, I can see that sine of angle A is opposite over hypotenuse, which in this case is h over b. And I can rewrite that to give me h is b sine A. And now let's look at this triangle here. Again, using standard trigonometry, I can see that the sine of angle B is opposite over hypotenuse is h over A, which I can rearrange to give me as h equals a sine b. Well, if this height here is b sine A, and the same height is also a sine b, therefore these two must be the same as each other. Therefore, b sine A must be the same as a sine b. And this can be rearranged in two ways. I'm going to divide both sides of my equation by the length. So first off, divided by b, and then divide both sides by a. So I will end up with sine A over A is sine B over B. And that's part of our sine rule. You can see if I were to draw perpendicular this way or that way, I'd end up with sine C over C as being equal to these two. I won't go through that here, but the principle is exactly the same. That's one way of arranging it. Another way, starting here, if I were to divide both sides by sine A and then divide both sides by sine B, I'd end up with this equation. So two ways of showing the sine rule. Generally speaking, if you're finding an angle, you would use this one. So the one you want to find is the numerator of the fraction. If you're finding a side, generally speaking, you'd use this way. But they're both variations on the same thing. Okay, let's have a look at question 11 from 9b. I chose this one because it's a little bit tricky. You've got algebraic bits in it rather than just numbers. We are given triangle ABC. You're not given the diagram, but I've just read the question and drawn the diagram. Always a good idea to draw the diagram. And you're given that the sine of y is 1 over root 2. And you need to show that x is 4 bracket root 2 minus 1. Tricky here to know exactly where to start, although we're not dealing with angle B, nor do I have side B. So I'm going to write out the sine rule with the lengths on top. So I'm going to use this variant here with A and C, angles A and C, sides A and C as my sides and my angles. So I'm going to start with C over sine C equals A over sine A. So that's the formula I'm going to use, that's the rule. I'm now going to substitute in the values I have for my particular diagram. So C is x over sine 30 equals 4 minus x over sine A. Well, sine A is sine y, and they tell us that sine y is 1 over root 2. Let's just simplify this a little bit. Sine 30, we should know from exact values of sine and cos and so on, that sine 30 from a 60, 60, 60 equilateral triangle, the sine of 30 is 1 over 2. Um, 4 minus x, if I'm dividing by 1 over root 2, that's the same as multiplying by root 2. Right, we just need to sort this out a little bit. Divided by half, the same as multiplying by 2, so that's 2x equals 4 root 2 minus root 2 times x. I want to show that x is this thing, so I'm going to move all my x's onto the same side. So I've got 2x plus root 2x equals 4 root 2. I'm going to factorize this. So I've got x times 2 plus root 2 is 4 root 2. So x is therefore 4 root 2 over 2 plus root 2. I'm going to slide this up a little bit now as I'm running out of space. This is not the form they wanted, so I'm going to rationalize the denominator. So x equals 4 root 2 over 2 plus root 2 times by 2 minus root 2 over 2 minus root 2. 4 root 2 times 2 is 8 root 2. 4 root 2 times a minus root 2. Well, the root 2 times the root 2 is 2. So the 4 times 2 is 8. That's a minus 8. On the bottom, I've got 2 times 2 is 4. This 2 times minus root 2, this root 2 times the 2, they cancel. That's why we do this. Root 2 times root 2 is 2, but it's a takeaway. So I have got 8 root 2 minus 8 over 4 take 2. 4 take 2 is 2. So I can divide this and this by 2. So I've got 4 root 2 take away 4, which I can rewrite as 4 times root 2 take away 1, which is what they wanted in the question.